Welcome. I would introduce briefly this initiative. In particular, I will give you an overview about the role of the building sector and explaining why it's pivotal, the profession of the energy manager. As you probably know, buildings now represent around 35% of global final energy consumption and almost 40% of the global energy-related CO2 emission. And in particular, in urban context, the highest quota of pollution is attributable to the building sector. In particular, you can see in this picture the Milan skyline on a windy day on the left and a non-windy day on the right during the winter, where the heating system that are mainly based on fossil fuel are operating. So 75% of particulate matter 2.5, so a small pollution in winter time, is related to buildings heating. And the other information is that the CO2 emission of buildings are expected to increase by at least 40% in 2050. Moreover, the overall building stocks currently account for around 245 billion of square meter, and more than a half of the existing stocks is likely to be in use in 2050. So the energy renovation of the existing buildings is a key element to shift to a low carbon building. So obviously we have also to deal with new buildings, especially in some countries like Africa, so mainly developing countries, but in other countries like North America, Europe, and so on, the main activity, the main focus will be the energy retrofit of existing buildings. And what we have to do, which is the strategy, so we have to use a combination of readily available technologies and approaches. So to achieve net carbon building is possible today. We have just to use technologies, design strategies, and technical systems that are available now, following the strategy that is showing this pyramid. So the first, we have to maximize the building's energy efficiency, mainly with passive strategies. Then second, we have to adopt high efficiency technical system and advanced control management strategies. And third, we have to maximize on-site or nearby renewable energy production and self-consumption. So following this strategy, we can transform existing buildings into nearly zero and net zero carbon buildings. So how we can do it, we need an energy manager. We need many energy managers that, as you know, the energy manager is a pivotal person whose task is to manage everything related to energy in a company, in a public body, or in any kind of structure. The energy manager must verify the energy consumption, optimize it, and promoting intervention aimed at energy efficiency and the use of renewable sources. So the scope of the energy manager is to analyze and assess an existing building and how the existing building or the existing structure is consuming energy, and put in practice all the interventions, all the strategies to strongly decrease this energy consumption and increase the renewable energy sources utilization. So that's why we think that this course, the energy management for the real estate, is particularly timely and important in this moment. And more in detail today, you will attend this webinar that is a practical application, a practical example on how you can apply your knowledge to an existing industrial building to strongly decrease its energy demand. Thanks you for your attention.
Thank you very much, Claudio, for Professor Claudio Del Pero, for your introduction, which is one of the teachers of the MOOC on which you are enrolled. And now I leave the floor to Daniele Forni. It deals with energy and resource efficiency, energy services, energy audits, measurement and verification, legislation and regulation. Since 2008, he has been technical manager of the Italian Federation for the Rational Use of Energy. So Daniele, the floor is yours.
I hope you hear me. Just please confirm, Alessandra. And
yes, we hear you very well.
Okay, thank you. I would like to thanks both Alessandra and Claudio for the introduction. By the way, my organization is also in charge of collecting the names of the energy manager appointed in Italy, as Professor Del Piero just showed in his slides. And in the next 3/4 of an hour, we will go through a simplified energy audit, all of the steps of it. This is mostly based on what is the EU regulation and the EU standards, but those are quite are good practice. So you can you may see very similar approaches also outside EU, because this is the Energy Efficiency Directive. It's just a collection of good practice on energy efficiency, and this is the definition of energy audit. And I would like to just highlight some of the point of this definition. First of all, it is a systematic approach. So you should have a systematic, so you should understand, have an idea on where to start, how to do it, and so on, not just going around. And then you should obtain an adequate knowledge. So each audit could be different. The knowledge is adequate, is not the perfect knowledge or in-depth knowledge. Every time you should decide with among the parties which is the level of knowledge you would like to have. And this could be applied to any kind of energy user, building, group of building, industrial or commercial, transport or service, and so on. And what you would like to do with this energy audit: identify and quantify cost-effective energy saving opportunities. So it's very important to the part it's cost-effective. So you have to present what is cost-effective for the user, the client. Are opportunities, because are opportunities of investment from the client in something he or she knows very well. So the buildings, the process, the services that are delivering. And you do not have just to identify the opportunity, but also quantify it. And at the end, you should report the findings, to present the findings of it. So this already gives you a structure of what an energy audit is. And we could go to some points of the energy European standard 16247. It's divided in 5 parts. 4 are real. The 5th is just on the requisite of the auditor, but the first 4 are a general part plus the specific part on building, process, and transport. Here, I know there are some attendees from outside Europe. So eventually you can refer to ISO 50002, that is the ISO standard on energy audit. But those are the European and the ISO standard are going in parallel, because in Europe we decided not to transpose the ISO standard and to go on with this European standard that has just finish at the end of in the second part of 2022 the revision, while the ISO 50002 is under revision at the moment. So I think we will have a convergency and so possibly at the next revision of the ISO 50002, I hope will be also transposed in Europe, and so we will have also for Europe a unique standard. But anyway, there are a lot of communication and expert working on both standards. So the things that I will say today you can find in the ISO 50002, most of them. And also the main difference is the ISO 50002 at the moment is just one standard, while as I told you, there are more parts in the European standard. Anyway, there are quality requirements for who is making the audit. So competency, confidentiality, objectivity, and transparency. And the letter 2, it's just obliges you to disclose any conflict of interest. So if it's already there, or as soon as it borns, you need to disclose to the client, because this could be an issue. Also because more and more now an energy audit is a tool for financing. So for going to financial institution and asking financing for to implement the opportunity that are highlighted in the audit. And what are the requirements of the energy audit? Audit must be appropriate, complete, and representative. So this should be decided between the parties. Once decide what should cover and how, if it's shallow or shallow, covering all of the site or the building or so on, or go deeper in some aspect, then it must cover completely what has been agreed. Must be representative, so based on real data, traceable. So you should give all of the reference where the data are coming from, what kind of treatment you do to the data, if there are any assumption and so on. So you must give all of the indication. Useful. So as already shown in the previous slide on the definition of the energy audit, you must evaluate, do a cost-benefit analysis on the proposal before listing them. And last but not least, because it is just in alphabetical order, verifiable. So you also must give the indication on how you will verify the result, the real result of, so the real benefit of once if this suggestion is implemented. And so to look at the steps of the energy audit as listed in this standard, we have a preliminary contact between the parties. This is more to decide, to understand what are the needs and how deep, what is the object, what are the boundaries of the energy audit. If we want a shallow one, if you already know that you want to concentrate on some specific aspect of the building, of the systems and services or process, then there is a startup meeting that this is mainly to understand how you could move inside the environment, who are the reference that will escort you and will exchange information, if there are any limits to the what are the days and the time you can go and visit the sites, if there are other kind of limitations and so on. So those are defined in this meeting. And then you start collecting data. All of these three, the first three parts could all be distant. So you don't really need to go to meet in person and to go to visit the site in person till the the site visit. Or with those data, you can also set up a measurement plan and eventually a sampling methodology. This is something more specific that has been introduced in the last revision of the standard, but you may need to measure or not. It really depends on case-by-case basis, and also sampling if you have many repeated energy user, or so you will sample instead of measuring all of them. And at this point, you really need to go on site. So this is the site visit. You really need to go there and see what's inside the building or the warehouse or a transport service and so on. From this visit, you may need more data, and so eventually set up a measurement plan for collecting this data or do some sampling and so on. And after the visit, could be one visit or could be more visits, because a site could be quite just like a building, but could be, I mean, a small, medium building or a very large building, or let's like a university campus or so on, just talking about buildings, but then there could be industries that are as big as district, town district, and so on. So it really depends what's the object of the audit. And then you start to analyze what you have collected from the data, from the site visit, and so on. And eventually you will go back and collect additional data to be able to finalize the analysis and then write down the report. And then last but not least, the final meeting to present the report, as highlighted already in the definition from the directive. So here I would like to just have with the help of Alessandra, we also set up some question to make this this lesson a bit more interactive. And so if you go on WooClap, and Alessandra should paste in the chat also the link to go there, or I don't see it, but I can copy and paste in the chat. Okay, now it's copied, and okay, now it's pasted in the chat, so you can go there, and we can okay, this is how to, and then you can just answer to this part on where, this first question on where you are coming from. So if just we have some, just if you can give, it should be simple. I tried to do it before and it was quite, so if you can finish up, and then we see that okay, so most of you are at least those who were able to answer are from Italy, or from, yeah, I would say from Italy or nearby. And okay, I don't see the others. I don't know if there's any issue in using the WooClap or so on. So just, anyway, we can also just go to the next question, just if you have, or I can leave you just some more time on this. I go on. Okay. So I would here we are also dealing what to collect, which data to collect on the site, with data to collect that are needed for the energy audit. So let's go on, because there are no other questions. And in this case, there are data that you are going to collect before starting the visit. Okay, so before having the visit. So typically, you would like to have general information on the organization, on the product or the service that they are producing. Even if it's just an office building, they are usually delivering some kind of service, and so you need to have to collect this kind of data to understand the process, what's going on inside the premises, the object of the audit. Then the vector, the energy vector that are used by the object, and the influencing factors. Influencing factors are factors that are influencing the consumption of the energy. So then we will come back to this later on, but it's something that you should ask, you should already have in your mind, because you should ask, you should be clear with the organization representative, with your interface with the organization, to ask this kind of factors that could be useful for your analysis. Any energy management practices that are already ongoing, not just a certified energy management system, but also other good practice in energy management. For instance, if an energy manager is present, or a central one at the organization, a local one at the site of the audit, and so on. Then we should understand, have the information about the process or the service that are made. Eventually, the transport. Please don't underestimate the transport, because also in the building there are transports. So there are the elevators, the escalators, and so on, and eventually some interface with the public transport, the private transport, and so on. So this could be an important part also, because now with the electrification of transport, more and more, also in a building, you will have to think about the charge and the interaction with the batteries of the vehicles. Then there are the service. I mean, the building is the envelope and the service. So the general services plus the auxiliary services. The auxiliary services are the services needed if you have a process, or that are in case you have a process, those are needed for maintaining the process, or are those that are representing the variable consumption, that is the consumption that varies with the opening time, for instance, or if we are just in a building, the opening time, or the number of people present inside the building, and the shifts, and so on. You should collect also information, the previous energy audit or feasibility study. So just to come back to this, okay, we had some more answer. I would like also to know, I show the next question is if you already have an experience in energy auditing, and in that case, in which sector. If you can give me a feedback, that would be a bit useful to better understand how eventually deep or shallow or go on the next slides and topics, and eventually on which kind of which sector to which sector give more attention. Okay, so far we don't have much answer yet. I hope also the others will be able to give feedbacks. So let's proceed. What you would like to collect during the visit. So those are the documents you will ask via email or phone calls and then emails, or emails, phone calls and emails and so on, because you will have to chase to have those data. It's very difficult to find a proactive person giving all the needed data at once. So during the visit, you should look at what it is the actual situation, because all of these data that you gather before are presenting something like a picture that would be maybe a staged picture or so on. Then you see that something, either a staged picture, either a picture that was made some times ago. So you really need to go and see what's really there. Maybe things are changed. Maybe the product of the service that are made in that site are already changed totally or partially, and so on. The environmental conditions that are inside. Theoretically, you have some indication of the environmental condition in a building. But also if the environment is clean or not clean. So this also gives you some indication on the personnel that is inside the building. So the attitude of the person. Then from the from the personnel, and different personnel could give you different information, but you could understand, for instance, from the maintenance person, from the responsible of the system, and so on, you could understand the hours different systems are working. And it's important to find the person who has that information. It could be, if you ask the general manager how many hours one system works, then probably the general manager could give you an information, but most probably it doesn't really know the correct information, so it could be misleading. So you need to find to ask the right question to the right person. So find operative person and ask them how many hours are on different system, how they are used, so how they are switched on and off. If there are more of them, how do you select what you use? Then many people be open and try to understand if there are ideas to rise the efficiency, because as Professor Del Piero highlighted, there are very different things you can do. One of these are soft improvements, so just requiring small changes. Then you may need to do some measurement, but this is not always needed. And then after the visit, you need to collect what is missing, because you understand that maybe there are new systems that were not in the documentation you received before, and so on. So, for instance, you should collect one thing that you usually need to collect any kind of audit you are going to do are the invoices of the energy vectors. And this is, and then you analyze the invoices. Structure of energy tariff is very different country by country, could be very different country by country, and even the kind of subdivision. For instance, you can have a flat tariff as usually for the natural gas, or you can have time of use tariff as, for instance, we have in Italy. In Italy, we have three different time of use tariff, but there could be, in the past, there's been a period with more time of use tariffs. In other countries, there could be more, different in winter and summer, and so on. So, and then you must understand, but it is very country specific, the excise duty, the VAT, and so on, because that could be specific of that kind of user, and eventually the user may not have may not pay the correct VAT for some reason. But you need to know also the cost of the energy, and you may also have access to interval data, meaning hourly or quarter hourly data. That's typically, at least in Italy, we have a quarter hour data for all of the electricity user from households up, or at least we will have in in a couple of years for let's say every user. And here there's is where each user can download those kind of data for all of the utility. Other ways, in other country, you may need to ask to the seller of the vector, or to the distributor, or even metering provider. That could be a separate provider just giving you the metering data, and you are paying this provider for giving those data in your bill. And now is very it's quite common to find site generation, mainly PV, but also CHP and so on. So you need the data and those quarter of an hour data or hourly data of the on-site generated electricity. Other ways, I mean, your data are missing a part, a smaller or bigger part. So what you will do, this is just an electricity, what you can have from your bills. Now I try to give you the next question. So what periodicity of energy data you usually have access to? So yearly, monthly, weekly, daily, hourly, or quarter hourly. This is because this is what you can get usually, at least in Italy, but in many other countries too, from one energy bill. So usually one energy bill could also give you the information on the on 12 months of consumption, maybe divided in by time of use, and here is the time of use scheme in Italy. So with 3 time of use, and here the subdivision of the energy by time of use, yearly energy divided by time of use, and here is month by month subdivision. But what you usually can also get are hourly data. The point is, you may get those hourly data. Those are the data that you get. That's the data of, for instance, of electricity that is from the grid. So, as you look at this is 00 is midnight. You see it's a bit strange situation, because you see in this case, and this is a real case, that you have a lot of consumption at midnight. So this should make you thinking, and eventually you can also see that this user doesn't buy much energy from the grid. So you need other data to see what is the hourly consumption. In this case, this may come from this kind of situation. So you can have this combined heat and power, a cogenerator, following the electricity demand. So in this case, you see it goes on, then produce, then at a certain point when the electricity demand, also the heat demand is lower, there's no heat demand at a certain point, so it goes to 0, but it never produces more than the electricity need of the site. But we can have a bit different case. For instance, if you have a PV system, you may see something like this. So you see that at least at certain times you are also selling, giving electricity back to the grid because the production is higher than the consumption in that moment. Anyway, so you have to combine more data just to obtain at the end the consumption, this yellow curve here. So we will concentrate on this yellow curve here, and you will have a quarter of an hour data or hourly data. And then what you can do with those data? Well, there are a number of things you can do. I see that some of you are used to have this kind of data, and what you can do with this? Well, something quite simple when you have your data is to prepare a load duration curve. In this case, it is very simple to make it. Think about how you would make this kind of curve. You can see that it's always going down, so you may understand how to do it. Otherwise, I will tell you in a while. And then you can see this could be very useful to see the peaks, how many hours or quarter of an hours you have those kind of peak each year. And then you can do some averaging. The monthly average, so the average month by month, the daily curve hour by hour by month, or the average day of the week yearly. So you can see that Sunday there's no much consumption, but there's some kind of activity in the site. Saturday is a bit different, and the other days are quite similar. And then you can focus on a particular day and see how this change month by month. And you see, for instance, there are some months where, the not too cold month, the colder months, where here you may have some maintenance, or you have less consumption for cooling or so on, for instance. And then you can also do something like this with all of those data. This is also called carpet plot. So you are visualizing in just one image all of the 8,760 data, in one picture, and you see how it goes during the year, but also during the day, and if there is any kind of strange thing or any strange data here and there, so you can immediately spot visually this kind. So this is very easy to do. You just do conditional formatting in Excel. And this one, the load duration curve, is just ordering by alphabetically, ordering the numbers from the highest to the lowest one. You can do similarly. You do for natural gas data, and here you have the monthly consumption, but you can also have hourly consumption. Now, at least in Italy, we have the hourly meters. Also, if you are a large user, also with the correction of not just the temperatures, that is already for domestic user, but also for the calorific value of the natural gas that is consumed. So that could be could make the data much more, let's say, reliable. And here again, we can have an average daily use, and you see that Sunday there are some kind of activity at a certain point. So these are the energy vectors, but you can also have liquid energy vectors like oil, gasoline, and so on for transport or so on. It depends where the where it is located. Now we are also looking for relevant variables. So if you are in a process, typically is the production, so the number of product by day, by month, by the period of time, and the mix of product. But please also try to think at other relevant variables, so the variables that are influencing the consumption. What could be also in, for instance, the number of work shift or man days could be other variables that you may like to use. And if you have heated an important consumption for the heating and cooling, well, typically the outside temperature could be important also for, in some cases, also for the industrial, for the production sector. But it's usually the one of the most important relevant variable for the buildings alone. Also with the humidity and yeah, work shift or opening hours also for the buildings. Okay, so now we use those relevant variables to do some kind of indicators. Those are some indicators for the dairy industry. That there's a quick example on dairy industry in the next slides. Those are real data that were presented some time ago at a conference we organized. And TEP is the Italian for ton of oil equivalent. That is a way we use to put together electricity and natural gas, and highlighting that are two different cases. And you see here there are also the emission, the ton of CO2, and there's more and more attention to emission and emission reduction within the last few years. So also the last version of the energy audit standard, European energy audit standard, suggests that you can present the or propose the CO2 emission as a as a way to do the analysis. Then to do the analysis, you need to understand what's inside the premises, so the inventory of the user and the data of the user. Typically the rated power, the number, then the kind of energy they use, and where they are located, in physically located and attached to which kind of needs, plant, system, and so on. And you can gather this information from technical data, commissioning documents, authorization, and so on. So you may get something like this. So a list of users, a list where this is for production, auxiliary services, general services, and auxiliary, and the rated power of those kind of system. The first part are just, yeah, all of these are electric powers. Then you may need, if you are looking for a process, you will ask for a site layout. So you see the productive lines, because usually is more than one. This is just different steps, but just one kind of path. In other kind of productions, you may have different paths. This is just a simplified, but in the reality, you may have different paths for different kind of products. Then you are receiving the raw materials or semi-finished, and there could be a warehouse or a, for this kind of material, eventually cold refrigerated warehouse. Then after the production, you have the palletization, and then a refrigerated product warehouse, and then that's for the shipping. So you receive and then you ship the products. But then you need to look at all of the systems and service you need for the production, for water, and eventually usually also softening for of it. Then usually in industrials you have a well, while in buildings you are connected to water network. Then there is a boiler room, then air compressor for industry, chillers room. Then in industry for internal logistics, the forklift, and so the charging station, and the transformer, the electricity transformer. So all of these have different distribution networks for electricity, for compressed air, for hot water, steam, chilled water, and so on. Then you have offices, workshop, laboratories, and data center is always present, smaller or bigger, here and there. And then you have the HVAC for office, data center, and eventually also for the production parts, the lighting. So we could divide these in auxiliary services and general services, because this is going on even if there's no production at that time. Then at the end, we have the treatment of wastewater and other byproduct or waste, but now is more byproduct. And then you should also check if and how to valorize those byproduct. So you have here auxiliary services. Then this is just some kind of offices and other parts not directly needed for production, but needed for needed for the site, for the organization. And then here are the general services. So this is just a scheme of, for instance, of the fresh milk for the milk. So you receive, you preheat, you skimmer, and then you cool it, you pasteurize it, and then you bottle it, and then you refrigerate before the shipping. Those are all of the steps, just for an example, because we will see some in the next slides. So what data you are going to collect, systems, conditions, use, and issues that there are always some smaller or bigger issues going on with the existing system, and the attitudes of the users and the maintainers and the proposal you may collect. So, and eventually you will need to do some spot measurement. So usually you may not have all of the data sheets before, so you will need to go and watch when you are getting in, for instance, the datasheet tables. This is one on one electric motor, and here you see the power of this motor in this part, depending on the connection, electricity connection of the motor, and the efficiency of this kind of motor. This is rusty but readable. In other cases, could be very, very dusty, and you see here I have to clean with my finger just to understand the kind of power this motor is, the rated power of this motor. So this is what happened on the field. Then you visit, for instance, the boiler room. You see the boiler itself. You see the kind of generator, the power, the rated power of this, and this is a steam generator, the capacity of the surface of heat exchanger, the maximum pressure, and or this is another kind of boiler that is a bit more readable, just to give you more kind of example. Then if you have some additional instrument, for instance, a thermal camera, you can check also the temperatures, and eventually if there are some kind of strange things that you can spot. You see from here the same let's say the same picture that was pictured before, the same boiler that was pictured before. You can see that you should not touch it, so be very careful when you are visiting. But you can also, if you are interested in knowing the temperature, you may have a look at the pressure meter. In this case, those are 10 bar of pressure. So the temperature is of the steam. So here we are steam, because we are 10 bars, and the temperature of the steam, if you look at the steam table, it would be around 180 degrees. What you can see with the thermal camera, if you are looking at some of the small pipings getting out from the upper part of the steam boiler. So you can, with the thermal camera, you can see if there are some energy waste, and you can also understand that the temperature. Here is a high pressure air compressor that is used to for the production of plastic bottles, where you bottle the milk, for instance, or you bottle the water if it were just for natural water. So these you can see you have here quite high temperatures, so you may think that you may evaluate if you can recover some of this heat. So if you are going to watch the process, one of the big user of energy could be air compressor. This usually could be up to 25% of the total of the electricity consumption could go in an air compressor, for instance, in the chemical industry and in other particular industries. Just to give you some indication. And in this case, there are other kind of data tag that you can find on the different kind of compressors, and you should read the rated power and eventually and the type of compressor, so you can then the manufacturer and the model. So and also the year could be very important, so you understand how old this compressor is. So when you are looking at the using data, and then the model is needed, so you can retrieve more information from the web. If it's a very basic model, you will see just the pressure. As you can see here, the pressure is quite high. We are around 9 bar in this case. That is quite an high pressure. Usually it's better to usually you may stay around 7 or just a bit above 7. 9 could be high, and this means that you have a higher consumption from this. On very basic compressor, you will have only an hour meter. On more advanced and modern ones, you can have the total of working hours, load hours, and motor starts. So this is an on-off compressor, so it's a more on-off screw compressor. So it has a valve to reduce the load without turning off the motor, because any electrical motor cannot turn on and off too many times an hour. Otherwise, it will overheat and then burn. So and then you burn the motor, so then you have to change the motor. So this is why those are the load hours, and you see there are a lot of non-load hours, so where there's a consumption of about 30% without any production of compressed air. And here is a more advanced compressor with variable speed drive, and so you see how this compressor, how many hours it works at different partial load. In this case, it works mainly at total, at nominal load, but take into account that in the same compressor room there was this other compressor working much more at partial load. So just to give you an idea of what you can see and what you can retrieve just playing with the control units of inside on those air compressors. And then you can also check the maintenance registry, maintenance log, to see the hours those compressor, the working hours in previous dates. That could be very useful to know how many hours it works or worked more recently. Similar things you do also with chillers. In this case, those are ammonia chillers for so large chillers for industry, because ammonia is not very requires a lot of attention, so it's more for industrial sector. And this is what you will do once collecting the data and the adjustment factor. Then you analyze the data, develop an energy balance, evaluate theoretical performance and actual performance indicator. And then once if are not comparable, you do some, you adjust a bit the model. then you possibly you compare to some performance indicator, existing performance indicator, and this lets you, this helps you to understand how many hours and how much energy is used by each energy use, and then to identify opportunities, understanding, looking at if it's an up-to-date energy machine or not, or if it's using too much compared to the usual other similar cases or so on. Then you identify opportunities, you do a cost-benefit analysis, and then you rank the opportunities and select the opportunities and rank them considering this cost-benefit analysis. And then you end the energy audit. So this is an example from the inventory I showed you before. You just asking to the people inside when you do the site visit how many hours per day that is system is used. Then you have the hours per year, and then you put a utilization factor that is the difficult part, obviously, because the other is quite straightforward. And in this case, is very low when we have more of these. So for instance, for low air compressor, you have usually at least 2 air compressor in a compressor room. And also you have more chillers in a refrigerator warehouse, and so on. So giving those utilization factors, you just see by multiplication rated power, you multiply by utilization factor, and then you obtain and then you multiply by the hours, and then you obtain the energy. This is the total energy from the bills, or from the bills plus on-site production, from the invoices plus on-site production, and so you need to go to converge to this with, in this case, there are other consumption. You don't need to arrive exactly to these numbers, because usually there are some other users that are not listed, or even if they are listed, there may be some small uncertain. I mean, this is quite an uncertain approach, so you don't really need to go to have this exactly the same. And then we also transform this in ton of oil equivalent, so then we can sum also the natural gas consumption, and have this in and present this in the total consumption and the share of it in ton of oil equivalent. The share could be much more similar, electricity to natural gas, if we were using watt hour of electricity and thermal watt hours, while ton of oil equivalent is more linked to the primary energy, so it's much higher for electricity. And at this point, we are going to find the energy performance improvement measures, so the opportunities where and to do this, we could have a plug and play once. So we just change a bulb, or requiring some changes. For instance, if we want to switch from steam to hot water, we will have to change a lot of, the pipings and many parts. And then there are process-specific ones. I don't know if you want to change a specific part of the production cycle, and so on. Usually, in an energy audit, you go for cross-cutting and plug and play, and eventually requiring some changes. While this part is more for production innovation, or someone who has a lot of experience in that sector. This is just a quick list of what you can do, for instance, for compressed air. So you reduce the delivery pressure. Roughly, if you reduce 1 bar of pressure, it's about 7% reduction. So 2 bars are around almost 20%, 16 or so on % of reduction. There are a lot of leaks in the low pressure networks, low pressure air distribution networks. Usually it's 20 to 30% is a typical case, but it can also be higher. And this means that there are a lot of energy and a lot of money going out there, because consider that when you use compressed air, at the end 80 to 90% of the electricity is transformed into heat. So just let's say 10 to 20% is becomes energy, delivered energy to the process, and then you can recover because because there's a lot of as I already said, there's a lot of 80 to 90% of the electricity is transformed to heat, and you can try to recover it. Then there are other also the chillers. If you are going to do if you are cooling, then there's a lot of heat that is dissipated. 3 times the electricity used by the chiller usually goes out as heat, but low temperature heat. So these is another things that you have to understand: the temperature of the heat that you can recover or that is needed by the system. If you are in a building, according to your distribution system, you may need 70 to around 70 or even 70 degrees if you have radiators, but you can go down to 40 or even less if you have fan coils or if you have a radiant system. In the same way, in process, you will find high temperature of water and high pressure of steam, but at the end, the user may need much lower temperature. For instance, in the example of milk, just for pasteurization, so for fresh milk, you don't need any steam. You can go pasteurization, it's around 60 to 75 degrees. And even if you have extended the longer extended shelf life or ultra high temperature, you go up to 100 something or 130 degrees centigrade. So you don't need the 180 degrees of steam that we saw before. It's just that in the past you raised a lot the temperature. Now we need also to check this because it's additional consumption. And what we can also do, other kind of waste is when you produce electricity in thermoelectrical facilities, a part of the energy of the fuel is wasted. So if you do this, if you produce the same amount of electricity, also recovering the heat with the CHP combined heat and power, then you could reduce the consumption of the fuel. And how you can make this the dimensioning of this system? Well, you remember this the load curve that I showed you before. It's pretty easy. You want to have this kind of CHP to work usually at least 60,000 hours per year. So if you have this diagram, you just take around 6,000 hours, and you have roughly the electrical power of the system. Then you should check how that you have enough time on, but that's more. This is just a first indication on the sizing that you can do pretty easily. Then there are other kind of energy performance improvement action, like a monitoring system that could be very useful also to collect more data to improve your evaluation and also to improve the management of the system. And to finish with another thing that could be very interesting, where you have cold and heat at the same time. like for instance in the dairy industry, but also in some buildings. Think about data center and so on. Heat pumps, and now there are heat pumps that you can order that are reaching 130 degrees centigrade, and new ones going much higher, already proven and in the real environment, that can go much higher. So this could be those could be additional opportunities. To finish, what you have to do at the end is prepare the energy audit report. So so you describe the energy performance improvement action, eventually the interaction, and for each energy performance improvement action, you give some economic indicator like net present value and profitability index and so on, and also the indication of how you do measurement and verification. But how you can foster the implementation of the opportunity? Well, for instance, you need to present this report to the client, possibly in front of some decision maker. And another a suggestion I can give you is to also to list in the report the non-energy benefit from each of the API you found. So for instance, lower maintenance, better environmental condition, better production, better reliability, and so on, because those are the points that are moving the decision makers. Okay, and this would be the end of your reporting. I mean, your auditing and reporting. And one last consideration, since we are talking more and more about sustainability of the production and of the service, the example was a simplified example of the milk milk bottling at the end, milk processing and bottling. And here is a look at the life cycle greenhouse gas emission of the milk. As you see, all we dealt with in our energy audit is roughly a 10% of the total greenhouse gas emission of the milk, if you look at the life cycle of the product. So it's more because there's in a way there's a part of the packaging is also here, but as you see, the larger part is outside the premises that we audited. So it's partly on before the let's say the process, or after processing. In this case, the cows phase are let's say almost two-thirds of the greenhouse gas emission are due to the cows that are producing the raw material. So just and we would need to expand our vision also downstream, so to the cows, and upstream, so to the consumption of the product or service that we are delivering. This will be more and more needed because there's much more attention to the life cycle greenhouse gas emission. All right, I just ran it a bit, and I took a bit more time than foreseen. I apologize for that. If there are other questions we can or particular interest in some specific application, we can have some minutes on this. For about the for the evaluation, I I didn't went much. Sorry. Okay, so you can also, thanks Bianca, she already pasted you in the chat the evaluation of the evaluation questionnaire that I kindly ask you to to do after leaving this this webinar. I'm available for further, if you have further information, you can write me and we can exchange via email, and you find my email in the last slide of this presentation that will be available shortly on the platform. If there are no other, I just check because sometimes I forget to. Okay, no, there are no other indication, and okay. So if there are no other, Bianca, I kindly ask you to give me a feedback on this. Otherwise, we can go in if there are interest or other question. Otherwise, we can. Okay, thank you very much, Bianca, and thank you very much for this for the interaction we had mostly in the first part of this presentation, and I hope you can pick some useful part from this. Bye bye.